So let's try another one. We've got a new function. 1 over x is our function. We're going to try to approximate the area bounded by the curve 1 over x and the x-axis from x equals 1 to 5. That's the interval that we're given. So we're trying to find the area inside this red boundary right here. But we don't have the tools yet to find that actual area, so we're going to approximate it using rectangles. And it tells us we're going to use 4 rectangles, so we take that interval from 1 to 5, and we divide it up into fourths. So it should be pretty clear that each one of those divisions is going to be 1 unit wide. So my delta x value equals 1. So that's why we have a width here of 1, and since we're going to keep that width constant for all of our problems, we're going to leave that as 1 all the way down. We're not using the midpoint method anymore. We're going to use the left rectangle sum. So that means that the height of our rectangles isn't going to be determined by this midpoint value, but instead we're going to look at in each interval, each subinterval, like this interval from 1 to 2, we're going to pick the left side. The left side of that interval is going to determine the height of that rectangle. So this point, which is on the curve, 1 over x, is going to determine the height of that first rectangle. So then when we move on to the second subinterval, we go from 2 to 3, we're going to look at the left side of that interval, which is over here, and we're going to get that point. So we're going to notice that each corner of the rectangle, each left top corner of our rectangle is going to touch the curve. And again, this is going to continue on for each one of these intervals. The interval from 3 to 4, we're going to pick the left end point of the interval, which is at x equals 3. That is going to give us the height of this rectangle. And then we've got one more rectangle here from 4 to 5. The left end point of that rectangle is going to determine the height there. Now these rectangles aren't the same area as the area under the curve. They're a little too big because each rectangle kind of sticks up over the curve. But we'll be happy with an approximation at this point. So if we take a look at the left value for each subinterval, the first left value was 1 right here. So that's why I put a 1 right there. The second one was 2. The third one, obviously, will be 3. And the fourth one will be 4. We'll get to the ith row in a second. Let's just finish with the numbers. Where do the heights come from? The heights of the rectangles, again, are determined by the function that we're given. This function is 1 over x. So we're just going to use our x value, and we're going to evaluate the function at each of those x values. So we've got the 1 over 1 is 1, and we've got 1 over 2 is 1/2, and 1 over 3 is 1/3, and 1 over 4 is 1/4. So those are the heights of our rectangles, the height of 1, height of 1/2, height of 1/3, and the height of 1/4. Those are the heights. Since the widths are all 1, in this case, it becomes also, those fractions are also the areas. 1 times 1 is 1, etc. All right. So, to find your generic ith row, not the first or the second or the third or the fourth, but any old row, we've got to figure out a pattern. You might notice that if I equals 1, then x equals 1. And if I equals 2, then x equals 2. Oh, well, that's easy. If I equals 3, x equals 3, I equals 4, x equals 4. So if I equals I, then x equals x. That's an easy pattern. Let's keep that consistent with the colors. X. So if I know what x is, I can find the height because I just use my function. So I'm going to plug in x into my function, and I'm going to get 1 over x. And we're going to multiply that by 1 to get our area. So our area of our ith rectangle is 1 over x. So we're going to add up all of these rectangles, starting with I equals 1, going to I equals 4 of the ith rectangle is 1 over x, so 1 over I. I don't believe that I did that. These should not be X, these should all be I. You guys didn't see that. Forget that ever happened. So we already saw these fractions over here, 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. And you can add those up, get a common denominator of 12. We've got, well, it says approximately, so I guess I won't worry about the exact answer. So I'll just punch this into the calculator, and we'll get from I equals 1 to 4 of 1 divided by I. And it tells me 25 over 12, which is approximately 2.083, or the exact value of 25 over 12. So that would be an approximate value of the area bounded by the curve 1 over x from the interval 1 to 5. It's too big of an answer because each one of those rectangles sticks up over the curve, but it's at the very least an approximation.